We're going to look at our last chemical required for growth, oxygen. So some microorganisms require oxygen to grow, and if you remember, that's because they're doing aerobic respiration. So remember that oxygen is the final electron acceptor in aerobic respiration. Okay, and then we have two very important terms here to know. So sometimes you'll hear microorganisms being referred to as aerobes and some of them being referred to as anaerobes. Aerobes require oxygen. And the word anaerobe, an meaning without, and aerobe is talking about oxygen. And anaerobe just means they do not require oxygen. All right, and then we have these terms here, which I would star in your notes. These are really important to know, so these will definitely show up on the quiz and the exam. So let's go through and talk about these, and then we're going to go look at some pictures. So the first term is an obligate aerobe. So the term obligate means required. And so an obligate aerobe requires oxygen to grow. So they cannot live without oxygen around. And then the next term we have is a facultative anaerobe. The word facultative means optional. So when we talk about a facultative anaerobe, a good example would be yeast. So they don't require oxygen to grow, but they would prefer to use it. So they actually do grow better in its presence. So we'll show you a picture of this in just a minute and it'll make more sense. And then we have obligate anaerobes. So remember, obligate means required, and anaerobe, not using oxygen, not requiring oxygen. And obligate aerobes actually are killed by oxygen. A good example here to think about would be C. diff or Clostridium difficile. So that's why they form an endospore when they get pooped out of the person's intestine, because the endospore is this protective dormant structure that will protect them from being killed by oxygen while they're out in the environment until they get ingested into the next person. And then when they sense that they're in somebody else's intestine where there's no oxygen, they're like, oh, I'm safe. I can hatch back out, become the living bacteria again, come out of that dormant endospore stage, and then they're safe. Okay, our next term is an aerotolerant anaerobe. Aerotolerant just means they tolerate oxygen, so they're not going to be killed by it. And they're an anaerobe, meaning they don't require oxygen, so they don't use it, but they're not going to be killed by oxygen. Okay. And then we have microaerophiles. So if you look at the term, micro meaning small, aero is talking about oxygen, and phil is to love. So they like small amounts of oxygen. So they're going to require just 2 to 10% oxygen levels, whereas the room air that we're breathing is 21% oxygen. So they just want a little bit of oxygen because they can use it, but they don't want too much of it. Okay, so I would definitely know the definitions, because I could give you a definition on the test or the quiz and then you identify which one it is, or I could give you a picture and then you have to identify which one it is. Okay, so let's take a look at these. So the first one we have is an obligate aerobe. So remember, obligate aerobe means obligate required, and aerobe, they use oxygen. So in these culture tubes, they're open to the air, and at the top where they're exposed to the air, there's lots of oxygen. In the bottom of the tube, there's no oxygen available. So these obligate aerobes requiring oxygen, they're going to grow at the top of the tube where there's lots of oxygen available. Okay, next we have obligate anaerobes. So remember, they're required not to have oxygen, they actually get killed by oxygen. So notice where they're growing at the bottom of the tube. So they're definitely not going to grow up at the top because they would be killed by oxygen up there. So they're going to grow down here at the bottom. Okay, and then we have these facultative anaerobes. So it's optional that they're not using oxygen, and they actually would prefer to use oxygen. So if we look at the tube, they would rather grow where there's oxygen available because they'd rather do aerobic respiration because you make a lot more ATP that way. But if there's no oxygen available, they could grow where there's no oxygen available. So maybe they're doing fermentation or anaerobic respiration instead. Okay, but you just don't make as much ATP. So you can see that there's not as many cells as there are up here at the top, where these guys are doing aerobic respiration. They're making a lot more ATP, and so they're able to divide more. So if you think about yeast, which are facultative anaerobes, they grow on the skin of the grape. They're exposed to lots of oxygen, whether on the surface of the grape, and they're doing aerobic respiration out there. But when the grapes are harvested, mushed up, put into a wine barrel, they end up using up all the oxygen as they do aerobic respiration, and then they're like, oh, wait a minute, I can't do aerobic respiration anymore. So the yeast switch over, and then they're going to do fermentation. Okay, so they're still able to make ATP, still able to survive, but they would prefer to do aerobic respiration if oxygen were available because they can make a lot more ATP. Okay, next we have the aerotolerant anaerobes. So they don't require oxygen. They're not going to use it, but they tolerate oxygen. Okay, they're not going to get killed by it. So they're going to grow evenly throughout the tube. They don't really care about oxygen at all. And then our last one would be these microaerophiles. So they just like small amounts of oxygen. So they just want the 2 to 10% oxygen level. So they're just going to grow a little bit below the surface where oxygen levels are lower, because at the surface, that's where you've got the 21% oxygen level. And that's actually too high from them, and that actually would kill them. So they don't want too much oxygen, they want just a little bit. So those would be your microaerophiles. Okay, so one thing about oxygen to know is that oxygen actually can be toxic. So oxygen is very reactive and will produce these reactive oxygen species. There's a number of them. So there's listed here these different reactive oxygen species. You don't have to memorize these. But basically what these reactive oxygen species are is they're free radicals. So these free radicals have unpaired electrons. And electrons like to be paired. They like to have a partner. And so what these reactive oxygen species or free radicals will do is they will go around the cell and steal electrons from things in the cell. And then that will cause damage to the cell. Because if you have these reactive oxygen species or free radicals stealing electrons from DNA, for example, then that will damage the DNA, and then that could kill the cell. Okay, so how do organisms deal with these reactive oxygen species and not get killed by them? Well, through evolution, organisms have come up with a way to deal with this. So some organisms are able to produce protective enzymes. Okay, you don't need to memorize the names of these protective enzymes that actually get rid of these reactive oxygen species, but they are around, and we even make these protective enzymes, and that's how we're able to tolerate oxygen and not get killed by it. Okay, but remember that we said that those obligate anaerobes like C. diff they're killed by oxygen. And why does that happen? So the reason they are killed by oxygen is because they don't make these protective enzymes to get rid of the reactive oxygen species. So that's why they get killed by oxygen. Oops. Okay, so that's an important thing to remember that I would star in your notes. So I would know why these obligate anaerobes are killed by oxygen. And that's because they don't make these protective enzymes to get rid of these reactive oxygen species, so they get killed by them. And then they just show how these protective enzymes work and get rid of these reactive oxygen species, and then just break them down into things that are not harmful, like water and just regular oxygen. You don't need to memorize any of these chemical reactions, but if you're just curious how these work, that's what they do.